Welcome to lesson 99 of Saxon Math Course 2. This lesson is about the Pythagorean Theorem. We're going to use the Pythagorean Theorem to find the unknown length of a side of a right triangle. Okay, so some definitions we need to learn, and the first thing is hypotenuse. Hypotenuse is this part, not the straight ones, the angle. It's always opposite the right angle. So the Pythagorean theorem only applies to right triangles. So there's always going to be a right triangle, and the one that's opposite of it over here is always the hypotenuse. And I think in the last video I called it the hypothesis. That's too funny. But it's hypotenuse. And then the legs are what make up the right triangle. Okay, the two shorter sides are the legs. And then the Pythagorean theorem itself is the area of a square constructed on the hypotenuse of a right triangle is equal to the sum of the areas of squares constructed on the legs of the right triangle. So we're going to learn this, right? It's going to be this plus this equals this. And that's the Pythagorean theorem. Okay, so let's take a look at this. The longest side of a right triangle is always called the hypotenuse. The other two sides are called legs. Every right triangle has a property that makes right triangles very important in mathematics. The area of a square drawn on the hypotenuse of a right triangle equals the sum of the areas of squares drawn on the legs. So if we look at this here, this 3, one leg is 3, one leg is 4, and then the hypotenuse is 5. To identify by their measures the hypotenuse and the legs of the triangle is shown. Well, which one's the hypotenuse? Which one of those is it? Is it the 3, the 4, or the 5? Hopefully you said that it's the 5. And then the other two are the legs. And the thing that's unique about this, as you can see, is that if you take this this 3 and you square it, you get 9. If you take the 4 and you square it, you get 16. Well, 9 plus 16 happens to be 25, which is exactly this 5 squared. 5 times 5 is 25. And that is the whole essence of the Pythagorean theorem. Okay, so to solve a right triangle problem using the Pythagorean theorem, we will draw the right triangle as well as squares on each side. Now, you don't have to do this normally, but we're going to do it just to help us out. So we're going to take, and you draw a square like that, and you draw one like that. And how many squares are going to be in this top one right here? It's going to be 6 times 6, so that's going to be 36, right? And 8 down here, we're going to have 8 times 8, right? We have it, right? That's going to be 64. Then we can add these two together, can't we? Because it told us that in the last slide. We add the two legs together. So that's 100. So we got 36 plus 64 equals 100. But remember, that was squared. So what's the square root of 100? To know what this, because the square root of 36 is 6. The square root of 64 is 8. So the square root of 100 is 10. So you know that this is 10. So in other words, 6 squared plus 8 squared equals 10 squared. That's how we get our answer. So we know our answer is 10. Get the idea? Let's take a look. All right, so it is 10 right there. All right, let's do a couple of these. In this triangle, we need to find what A is. So they're being a little bit tricky here because they're giving you the hypotenuse. So you're going to have to change it up a little bit, but it's not too bad. Think you can do it on your own? See if you can. Then restart the video. Okay, so we know that we got one leg plus a leg equals the hypotenuse. Well, we know the hypotenuse is 13. We know the leg is 12, and we don't know what this one is. So now we got to do our boxes, right? We've got to build these big boxes up on here. So we're going to square both of these. And you're going to take 13 squared, and that's 169. And take 12 squared, that's 124. So now we know that our missing leg plus 24 equals 169. So we got to isolate this. So we're going to subtract 124, from both sides. That's 5, and that's 4, 45. Did I do that right, or did I make a mistake? Oh, it's 25. I did make a mistake. It's 144, not 124. Silly me. Let me back that up. Well, you guys are all screaming in your rooms about that one, weren't you? All right, so 12 squared is 144. Oh my goodness gracious. And 13 squared is 169. All right, and then we got a question mark. All right, so then 144 minus 144 minus 144, we get 25, and the square root of 25 is 5. So we know that A is 5. All right, forgive me for my mistake. There's what it would look like. All right, let's look at another one, see if I can do it without making a mistake. Okay, so find the perimeter of this triangle. So it's not asking you for what the hypotenuse is, but you're going to have to figure what it is in order to get the perimeter. So let's do it. Let's use a formula. All right, we got one leg plus another leg equals the hypotenuse. All right, so the hypotenuse here is C, so we can't do anything there. We got a 3 and we have a 4. All right, so now we got to square them, right? Because these are squared. We square them. Remember that? So squared, squared, squared. So 4 times 4 is 16, plus 3 times 3 is 9. So what does 16 plus 9 equal? It equals 25. And what is the square root? When we break these all back down, this becomes a 4, this becomes a 3, and this becomes a 5. Okay, so we know that's a 5. So now we can add the perimeter. 5 plus 4 is 9, plus 3 is 12. Okay? All right, great. Hopefully you're getting that. All right, see if you can do this one here. See if you can copy this right triangle and draw squares on the sides. And then write an equation that shows the relationship between the areas of the squares. You don't have to solve it. This one here, you're just going to write the equation. You're going to write the equation. So pause it, see if you can do it. Start it back up. Okay, so I'm going to go my leg plus my leg equals my hypotenuse again. So I'm going to go A squared plus B squared equals C squared. That's how I would do it. And that's going to equal the big numbers. And there it is. And that is the formula for the Pythagorean theorem. Just remember that it only applies to right triangles. It will not apply to this triangle right here. Okay? It won't apply to this triangle right here. They have to be right angles, right triangles. Okay? So how would we figure that out? So the side lengths of these are given. Which of these is a right triangle? Which one is? They all look like right triangle. Like, couldn't you put one? You could put one here. You could put one here, and you could put one here, right? But can you figure out which one really is? In order to do that, you're gonna have to use the formula. So I'll do A for you, and then you do the other two yourself. So A is going to be 4 squared is 16, plus 5 squared is 25, and 6 squared is 36. Well, does 16 plus 25 equals 36? It doesn't. So this is not a right triangle because the formula doesn't work. It doesn't work. All right, let's look at B. 7 squared is 49, plus 7 squared is 49. Does that equal 10 squared of 100? Does that equal 100? It doesn't. It doesn't. Bam, that's not a right triangle. Let's do C. 5 squared is 25. 12 squared is 144. That's going to equal 169. Does 13 squared equal 169? It does. It does. This is our answer. C is our only right triangle, even though all three of them looked like they were. Okay? All right. Here's yours. Show me you can do it. Put it on pause. Solve it. Restart the video. All right. You should have come up with 24 feet is the perimeter. So your missing number, you should did your 6 plus your 8 equals your hypotenuse. So this is 36 plus 64 equals 100. So this equals to 10. So 10 plus 8 plus 6 is 24. All right, hopefully that's what you did. There's your TIDs, number 10, number 13, number 18. Send those in to me tonight. Bring your questions. We'll work on this all tomorrow. I'm sure you'll have lots and lots of questions about this lesson. I know it's new for everybody. It is a new concept, but it's something you will use the rest of your math career. So make sure you learn it and take it seriously, and we'll see you tomorrow.